Acids and bases in the laboratory. Let us understand it with the help of an activity. Take 4 test tubes and label them as A, B, C and D. Take 5 milliliter of hydrochloric acid, acetic acid, sodium hydroxide and ammonium hydroxide respectively. Add 2 to 3 drops blue litmus solution in each test tube. Now observe it. You will observe that the test tube A and B turns blue to red, while the test tubes C and D will remain same in the blue litmus solution. Add 2 to 3 drops red litmus solution in each test tube. Now observe it. You will observe that the test tubes A and B will remain unchanged to red litmus, while the test tubes C and D will change red litmus solution to blue. Add 2 to 3 drops phenolphthalein in each test tube. Now observe it. You will observe that the test tubes A and B does not give positive test with phenolphthalein, but the test tube C and D gives pink color with phenolphthalein. Add 2 to 3 drops methyl orange in each test tube. Now observe it. You will observe that the test tubes A and B gives red with methyl orange, but test tubes C and D gives yellow color with methyl orange. Reaction of acids and bases with metals. Set the apparatus. Add 5 milliliter dilute hydrochloric acid and sodium hydroxide respectively. Add a few pieces of zinc granules to both the test tubes. Close the mouth of both the test tubes with delivery tube, and the other end of the delivery tube should dip in the soap solution. Now observe them carefully. You will observe some bubbles. A gas is produced in both the test tubes. The gas evolved passes through the soap solution. Take a burning candle near a gas-filled bubble. Observe it carefully. You will find that a pop sound is produced. From this activity we can conclude that acids and bases react with metals to give hydrogen gas and their corresponding salt. Reaction of metal carbonate and metal bicarbonate with acids. Let us explain with the help of an activity. Take 2 test tubes, label them as A and B. Take about 0.5 gram of sodium carbonate Na2CO3 in test tube A and about 0.5 gram of sodium hydrogen carbonate NaHCO3 in test tube B. Add about 2 milliliter of dilute hydrochloric acid to both the test tubes. What do you observe? You will observe that the gas is evolved with the brisk effervescence. Pass the gas produced in each case through lime water, that is calcium hydroxide solution. On passing the carbon dioxide gas evolved through lime water, it turns milky due to the formation of calcium carbonate. On passing excess of carbon dioxide gas, calcium carbonate converts into calcium hydrogen carbonate, which is soluble in nature. From this activity we conclude that metal carbonate and metal bicarbonate reacts with acids to give carbon dioxide gas, salt and water. Neutralization reaction. Take about 2 milliliter of dilute NaOH solution in a test tube and add 2 drops of phenolphthalein solution. Observe the color of the solution. It turns pink color. Now add dilute HCl solution drop by drop in the solution till its color disappears. Now add a few drops of NaOH to the mixer. Does the pink color of phenolphthalein reappear? Yes, it does. Hence, from this activity we have observed that the effect of a base is nullified by an acid and vice versa. A neutralization reaction is taking place. The reaction between an acid and a base to give a salt and water is known as a neutralization reaction. Reaction of metallic oxides with acids. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. You will observe that the color of the solution becomes blue-green and the copper oxide dissolves. The blue-green color of the solution is due to the formation of copper chloride in the reaction. It is a reaction between a metal oxide and an acid to give metal salt and water. Do all acids and bases produce hydrogen ions? Click on any one of the buttons to check the whatever the bulb glow for all substance or not. HCl produces hydrogen ions or H+ aqua in solution which are responsible for their acidic properties and conducts electricity through the solution. Glucose does not conduct electricity. Due to that, it does not furnish ions. NaOH produces hydroxide ions OH negative aqua in solution which are responsible for their basic properties and conducts electricity through the solution. Alcohol does not conduct electricity. Due to that, it does not furnish ions. Action of acids or bases in water solution. Let us explain with the help of an activity. Take about 1 gram solid sodium chloride in a clean and dry test tube and add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Yes, a gas is formed during the reaction. Test the gas evolved successively with the dry and wet blue litmus paper. The dry litmus paper does not give any color while the wet blue litmus paper turns to red. This experiment suggests that the hydrogen ions in HCl are produced in the presence of water. The separation of hydronium ion from HCl molecules cannot occur in the absence of water. pH. pH is a measure of concentration of hydrogen ions in a solution. The P in pH stands for potens in German, meaning power. Thus, pH is defined as a negative logarithm of hydrogen ion base 10. On the pH scale, we can measure pH from 0, very acidic, to 14, very alkaline. The pH of a neutral solution is 7. Values less than 7 on the pH scale represent an acidic solution and more than 7 is base. Let us check the pH of the given solution. Dip the universal indicator in each solution and observe the color change. Compare with the universal indicator. You observe that gastric juice turns dark orange with pH between 1 and 2. Lemon juice turns orange with pH between 2 to 3. Pure water turns light green with pH between 7 to 8. Milk of magnesia turns light blue and its pH is between 10 to 11. Sodium hydroxide turns dark blue and its pH is between 13 to 14. Importance of pH in everyday life. When pH of rainwater is less than 5.6, it is called acid rain. When acid rain flows into rivers, it lowers the pH of the river water. The survival of aquatic life in such rivers becomes difficult. Plants require a specific pH range for their healthy growth. To find out the pH required for healthy growth of a plant, you can collect the soil from the various places and check the pH. Put about 2 grams soil in each test tube of different samples and add 5 milliliter of water to it. Shake the contents of the test tube. Filter the contents and collect the filtrate in a test tube. check the pH of this filtrate with the help of a universal indicator paper. The best soil pH for growing plants is between 6 to 7.5. It helps for plants' growth and development. Do you know that our stomach contains hydrochloric acid? Hydrochloric acid is essential for the digestion of food. Sometimes our stomach produces excess acid which causes pain and irritation. This condition is known as acidity or indigestion. To get relief from this condition, milk of magnesia is used as an antacid. Milk of magnesia contains magnesium hydroxide, which is a mild base. It reacts with excess acid present in the stomach and neutralizes it. This is an example of neutralization reaction, that is, reaction taking place between an acid and a base. In our everyday life, we observe many examples of neutralization reactions. For example, a honeybee's sting causes pain and irritation as it contains formic acid. Similarly, when a bee bites, it injects formic acid into the skin, which causes pain and irritation. To neutralize the effect of formic acid, baking soda or sodium hydrogen carbonate or zinc carbonate can be applied on the skin for relief. Tooth decay starts when the pH of the mouth is lower than 5.5. Tooth enamel made up of calcium phosphate is the hardest substance in the body. It does not dissolve in water, but is corroded when the pH in the mouth is below 5.5. Bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth after eating. The best way to prevent this is to clean the mouth after eating food. Using toothpaste that are generally basic for cleaning the teeth can neutralize the excess acid and prevent tooth decay. Sodium hydroxide. Sodium hydroxide is commonly called caustic soda because of its corrosive action on animal and vegetable tissues. Large quantity of sodium hydroxide is prepared by the electrolytic process called the chlor-alkali process. In this method, salts get dissolved in water as shown here. This solution is called the brine solution. Filtered brine solution is passed into the electrolysis chamber. When electricity is passed through an aqueous solution of sodium chloride called brine, it decomposes to form sodium hydroxide. Saturated brine enters anode compartment where chlorine gas is produced. Chlorine gas is given off at the anode and hydrogen gas at the cathode. Sodium ions migrates with the diaphragm of cathode compartment combining with OH ions to form NaOH. Sodium hydroxide solution is formed near the cathode. 32% of sodium hydroxide collects in receiver and passes into the triplet affected evaporator, and 98% of sodium hydroxide is collected in the receiver. Bleaching powder. The chlorine is produced during the electrolysis of aqueous sodium chloride or brine. This chlorine gas is used for the manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slag lime or CaOH2. Bleaching powder is represented as CaOCl2, though the actual composition is quite complex. Washing soda. Washing soda is sodium carbonate dihydrate. The chemical formula is Na2CO3-10H2O. Washing soda is prepared in laboratory. The apparatus setup is shown here. Limestone is taken in flat bottom flask and caustic soda is taken in large boiling tube. Pour the dilute hydrochloric acid to the flask with the help of thistle funnel. Limestone reacts with hydrochloric acid to generate carbon dioxide. The gas is now passed to the concentrated sodium hydroxide till white solid appears at bottom of the boiling tube. The white solid is sodium carbonate. Sodium carbonate can be obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. Water of crystallization. Water of crystallization is the fixed number of water molecules chemically attached to each formula unit of a salt in its crystalline form. Let us explain with the help of an activity. Heat a few crystals of copper sulfate in a dry boiling tube. What is the color of copper sulfate after heating? We observe that the color of copper sulfate changes blue to white on strong heating and also form water droplets on the sides of the test tube. Add 2 to 3 drops of water on the sample of copper sulfate obtained after heating. What do you observe? Is the blue color of copper sulfate restored? Yes, copper sulfate regains the original color. From this activity, we conclude that copper sulfate contains water of crystallization. Plaster of Paris. Plaster of Paris occurs in nature as gypsum and the anhydrous salt as anhydride. It is prepared by precipitating a solution of calcium chloride or nitrate with dilute sulfuric acid. Acids and bases. Look here, there are some properties of acids and bases in the tabular form. Substances that are used to identify acidic or basic nature of substances are called as indicators. Let us add each of the indicators one by one in the test tubes to check whether it is an acid or a base. The Arrhenius Theory. According to the Arrhenius concept, an acid is a molecular substance that breaks up in aqueous solution into hydrogen ions and anions. An Arrhenius base is defined as a substance that releases hydroxide ions in aqueous solution. The Bronsted-Lowry acid-base theory. In the Bronsted-Lowry theory, an acid is a proton donor and a base is a proton acceptor. The theory portrays the ionization of hydrogen chloride in this way. HCl plus H2O gives H3O plus chlorine. Here water is a reactant. The acid molecules donates hydrogen ions or protons to the water molecules, so the acid HCl acts as a proton donor. An ammonia molecule accepts a proton from a water molecule. NH3 plus H2O gives NH4 plus OH. NH3 acts as a Bronsted-Lowry base.